Thank you, thank you. Welcome, and I'm really, really excited to see all these budding scientists in the audience. This is really exciting. Hopefully, some of the stuff that I talk about today will encourage you to explore the fields of science and environmental science, hopefully, and learn all about rivers and streams and all the animals that live in them. It's important for protecting this planet and continuous to the future. So I'm very happy to have you all here. The other scientists and public too, the adults, thank you, but you know. So one of my goals today is, and when we were doing this work this summer, we had discussed, wouldn't it be really neat to kind of show some of these images and videos in the depths of winter. So I'm bringing summertime for just a little reprieve, a half-hour reprieve of winter. You'll have a little bit of summertime. So I'm going to talk about the Adirondack, Adirondack's Hudson River and mussels. So we all know the Hudson River. It's right in our backyard, I think in that direction, and quite familiar with it. So I'm going to talk a little bit first about mussels and what native freshwater mussels are and why we're interested in them. So native mussels are part of the class of mollusks, bivalves, and they're in the family Unionidae, which is we call the Unionids. They make up this group. They're the most imperiled or endangered group of animals in all of North America. About 70% of all species in North America are in some degree imperiled. And why is that? It's because they live in freshwater ecosystems, and our rivers, lakes, streams are often the places where all the things that we do on land and in the air, all the poisons and fertilizers and all the nasty stuff that we do end up funneling down into the waterways. So the freshwater animals are often really impacted by what we do on land. So why do we care about mussels? They're really not a very attractive animal. They don't really have a brain. They have no eyes. They just have one foot that they use to stick in the mud and kind of pull themselves around. They live in the mud, which is kind of disgusting. But they do really important things. When they're in that mud, they're moving around here. You see a trail. This is the mussel pulling itself through the sediment, and it does things like, kind of like turning over your soil in your garden in the spring, really making that soil come alive. They do that in the bottoms of our rivers and streams. But one of the really important things is that they catch things out of the water column. So as the water's going by in a flowing river, there's all these little pieces of leaves and little organic matter that the mussels grab out of the water. They filter it out with their siphons, and they catch it on their gills, eating it. And by doing that, then they provide it to other plants and animals that aren't able to catch that food and provide it on the bottom. So where we see abundant and diverse native mussel populations, we'll also see abundant and diverse like insects, macroinvertebrates, other things that live among them. So they're very important for the ecosystem. Some of the interesting things about mussels is that they do reflect the health of the watershed for all those things that I've talked about. They can live pretty long, 150 to 200 years. We've aged mussels in the Hudson River at 80 years. So we know in the Hudson they're living at least that long. And you can age a mussel by counting the rings in its shell. Just like when you cross-section a tree, you can count the rings to see how old the tree is. You can do the same thing with mussels in their shells. North America supports the greatest diversity of native mussels by far, about 300 species. But again, about 70% of those are in some degree imperiled, as are the species in New York State. New York State has about 50 species. They capture pharmaceuticals and toxins, so we can track the concentrations of some compounds in the waterways by looking at the tissues of mussels. But one of the more charismatic things, so we have this kind of ugly, nasty mussel that lives in the sediment. One of the neat things about them that you can talk about at the dinner table is that they fish. They know how to catch fish. And so they're stuck in the mud, they can't really move around, but in order to reproduce, they have to be able to get their young attached to the gills of fish. To the gills of fish. Why do they have to do that? Well, they evolved from like clams and mussels in the ocean that broadcast their young, just spray it out into the water, and the currents disperse them everywhere. But if mussels were to do that in a stream that's moving in one direction, if they broadcast their young, it would just all get washed downstream. So they'd never be able to stay or move upstream in a river, right? But evolution was very good to mussels, and they had an adaptation that allowed them to have their mantle, this outer covering that forms their shell, that they have their siphons. It'll form to mimic a bait fish, like a little minnow. And in this upper video, this is a Lampsilla species, that minnow will twitch when a fish comes in, and it'll attract the fish in. When the fish goes in to explore and grab onto that minnow, the mussel will release, and you'll see this in a second. It'll spray its larvae to attach to the fish. And you'll see that they're just little spring-loaded little clamps, and they'll grab onto the gills, and they'll absorb nutrients to the fish. Doesn't hurt the fish, but they'll stay on there for 2 or 3 weeks, and until they form into little child mussels and drop into the sediment. If they fall into a good spot, then they'll stay there and grow into an adult. But so these are those little glaucidia that are attached to the gills. And there's lots of things. If you go online and look at fishing lures of mussels, you'll have all kinds of videos and lots of things to learn. So now the Hudson River. So we know all about the Hudson River, right? It's about 315 miles long, the watershed of over 13,000 square miles, and it's one of our nation's most important waterways, historically, economically, ecologically. And here it is, from Albany to New York City. This is the tidal portion. And if you were to Google the Hudson River and look for information about the Hudson, 95% of the information is going to explore this portion of it. And this is what it looks like from New York City, the Collar City Bridge up in Troy, downstream. But the Hudson really, the whole length of it, starts from the Adirondack Mountains, proceeding all the way down to New York City. And so I'm going to focus on this portion, north of Albany, upstream of Albany, where in this section, it's a series of dams and pools. Many times it's the navigational portion. Ships can go up the Hudson, ships and boats can go up the Hudson to this point, and then they can go up to Lake Champlain. This part is not navigable. You can technically take a boat from New York City all the way up to almost Glens Falls here, right? There are portions you have to take in and out of this portion. But so this section that I have circled in red, we've been doing quantitative or very refined surveys to know exactly, to be able to calculate numbers and densities of mussels across the riverbed since 2013. And this is the portion that had a Superfund remediation project from Fort Edward to Troy, because high levels of PCBs were in the river. So there are areas that were dredged to remove sediments and then replaced with clean sediments. And since mussels live in those areas, we figured we should find out how many mussels are removed and then whether they're coming back after the remedy. So we surveyed over 3,000 sites, requiring divers because it's deep water. And these are the pools from the source of contamination in Fort Edward down to Mechanicville that were the majority of our sites. So just looking at this, the average densities, I'm going to put that in there. there are a lot of mussels in this section of the river, between 15 to over 65 mussels per square meter. So mussels live in little dense beds, we call them. They tend to aggregate in certain areas. So there'll be some areas of very densely populated mussels and then areas where there's few or no mussels at all. These numbers average that all out in the area of the sampling. So this is very densely populated. We actually, and we published this in 2013, some of the densities at sites were the highest recorded densities anywhere in the literature for freshwater mussels. So the Hudson River is very, very productive for freshwater mussels. If you look at, you can convert by measuring the length of the shell and knowing how much biomass the mussel has, of just elliptio, which is the dominant species here. We were able to calculate how much filtration is the mussel population doing. And we found that of the over 300 million mussels in this 35-mile stretch of river, they're filtering 780 million gallons of water every day. 780 million gallons. To put that in perspective, because that's a number that only Elon Musk can relate to. It's about 17 times that of the Albany wastewater treatment plant. So these kind of figures kind of help us put like human-related value on a natural resource, right? So they're providing a really critical service for us. So now, we sampled this middle section of river. While we're doing these, since 2013 when we started, we continue to follow the recovery of mussels in injured areas. We keep asking ourselves, are there mussels in the northern parts? And we looked at the literature, we looked at old studies. We can't find records of whether there's mussels in the uppermost portions of the Hudson River. So we kind of had an off year and we decided, I talked to some of my friends in DEC, and we said, let's go out there and see. So this next series is going to be a lot of images and videos of some of that field work. So we started at the beginning. Henderson Lake is the headwaters of the Hudson River. Now technically, if you were to Google the headwaters of the Hudson River, it'll be Lake Tier of the Clouds. And that is the highest point in the watershed of a water source for the Hudson River. But if you follow the river up, meandering through the Adirondacks, the last place where the river exists is the effluent of Henderson Lake. So this is technically our headwaters for the Hudson. Has anybody in the audience, besides the crew that went up with me this summer, been to Henderson Lake in the headwaters, this area of the Hudson? We've got one. Yeah, not two. We got another person back there. Okay, a couple people. It's not very well known. This is a tract of land that was acquired in 2003 by Open Space Institute. It's about 10,000 acres. And otherwise, this Upper Works trailhead was privately owned by the mining industry. Very historic, and it also takes some effort to get up there. So this is our state in a private vehicle transporting all of the kayaks and canoes that we used. We've got two kayaks back here, kayak in the back there, going up to the headwaters of the Hudson. And this is the map of the 200 acres that the Open Space Institute maintains. They transferred the rest of that to New York State. So now it's trailheads for Mount Marcy, better parking than the Keene Valley. But you pass a lot of historic things. There's this blast furnace. You'll see a picture of that in a minute. And I mean, interestingly, this McNaughton Cottage was where in 1901, then Vice President Teddy Roosevelt learned that President McKinley had been shot. He was staying at McNaughton Cottage and hiking up Mount Marcy when he learned that he had to get back to Washington, D.C. and become the next president of the United States. So it takes an effort from the parking lot. It's about a half-mile portage to get to the lake. So we had to carry our canoes, use carts and carries for the kayaks. And this, across this bridge, you end up crossing over the very beginnings of the Hudson. This is part of our crew. These are all DEC folks and our intern, Jake, which you'll meet again in some other pictures. And then at Henderson Lake, there's a small dam, and right here, where this water comes out, that's the first part of the Hudson River. So I had done some reconnaissance about 10 days prior to our big expedition up there, and it was beautiful, accessible, figured out how to do this. Then 10 days later, we bring up the crew, and the water levels, we had had a high rain event 3 days prior to our expedition, and the water levels, because this is in a bowl, the water levels jump like 2 feet in the lake. So if you're trying to search mussels by snorkeling or by looking through the water column, it kind of defeated the purpose a little bit. So we paddled around different sides of the lake. We were looking for like middens of shells where otters or muskrats, mink might have dined on some mussels and left some shells. But this is Henderson Lake and the beautiful mountains around. But we found no evidence of mussels. So in science, the absence of evidence isn't the evidence of absence, right? You really can't be sure that there's no mussels in this lake. We really want to go back and do some more surveys. But then, so if you walk down, as you walk down to the parking lot, that half mile, it's worth stopping in and kind of looking at the Hudson, because these are areas where, I mean, you can walk across the Hudson, you can, throw a rock across. It's just beautiful, and the water clarity was great. So, and then also on the way out, here's us trying to get a self-inclusive portrait here, which was only somewhat successful. But this is the blast furnace that for the iron mining efforts in like 1854, I think it was built. It's like 3 stories tall, and the OSI is maintaining these historic properties. You can't miss it. When you drive by, you just go, wow, what's that? And then also as you drive out, the river changes. This is also the Hudson River. It looks like a beaver pond. We also didn't survey in this area. Our next survey area was starting at Harris Lake, and that's in Newcomb. And then if you paddle through Harris Lake, you can get to the Hudson River. I had Sasquatch join me, which isn't really Sasquatch. This is Jake. Jake, our intern, he was a volunteer intern. He goes to Middlebury College, and he interned, and he was just as enthusiastic. And this is how, if you want to do this kind of work, this is how, as a college student, you get into the field, is that you volunteer for things like this, and you join scientists in the work that they do to get experience. And he was just as happy and enthusiastic. Well, maybe not. He probably liked the field work the best. But he was as happy doing curation in the collections and was very careful handling shells and labeling and packaging. And then he'd also join me in the field and do a good paddle. So we paddled through Harris Lake. And as you get to where the river is, it lets you know that if you go downstream, you will hit New York City. But we paddled up as far as we could. Some beautiful areas, looking at the side slopes and the shorelines for shells, stopping and doing some snorkeling surveys until we could go no further. We hit this very rocky, rapid area, and obviously, boulders as far as you can see. So we stopped there, did one more survey at the base of this, and found actually no mussels there. It was right here. And then paddled back down. We ended up finding some mussels. They were a little rare, but we did find mussels, 2 species. And this is what we always take we measure the minimum and maximum length of all the mussels, identify species, and record everything. We put the live mussels back and keep any dead shells that we find for collections. So then another day, I decided to just sample by myself because these were sites that required a lot of driving. So the access to these areas in the Adirondacks can be difficult. So I saw that there was a put-in at Polaris Bridge, but in order to get there, I had to go all the way up through Newcomb and then drive these very remote back roads, like 8 miles on like logging roads to get to this gate where then I had to hike down to the river. But that brought me to the Polaris Bridge, which is a snowmobile crossing. And it was for the timber industry. If you can imagine, during the timbering years, they would cut a lot of the lumber, and in the spring, they would be dumping the logs into the Hudson River and waiting for the high flow, and then riding those, literally, some of the logging people would be riding the logs down the river to get to Glens Falls to the paper mills. But that doesn't happen anymore, which is a good thing. But so these are times of low water flow. And I sampled wading. I'm using a viewing bucket. So I take a 5-gallon pail and I cut the bottom out of it and I put a plexiglass bottom on it. And then if I look in the water through that, it's kind of like a glass bottom boat. And I can see mussels if they're in the shallow waters. So it's a tool for mussel surveys called a viewing bucket. And so I did some visual surveys. I did find some dead shells along the shoreline of some kind of mammal that probably ate them, but I didn't find any live mussels. So the next spot is only like 5 miles downstream. It's called Goulee Club Road. But in order to get there, it's all seasonal roads. You have to go all the way through Blue Mountain Lake, down to Indian Lake, and then up Goulee Road to get to this site. And then a short walk down to the river. And I did a wading survey right at the base of this tree and found a few live mussels, some dead ones. And these are starting to get a little chunkier. That's one thing that we notice is that they have thicker shells as you go downstream. So then we jumped. There's a large span where it's really too challenging at this point to access because that's where the big whitewater rapids, the gorge is, where they do like rafting stuff. And so mussels tend to like, and it's not surprising, you could probably guess this, that they like to live in sediments that don't get washed away. You know, if they're going to be in flow and get washed downstream, the mussel's going to go with it, right? So we tend to find mussels where there's stability in the sediment. So a lot of these really high flow areas that are churning a lot, we're probably not going to see a lot of mussels. So our next spot was putting in kayaks and canoes at one point and then picking them up at the lower point, doing like a 7-mile stretch of river. And from the boats, kayaks and canoes are great because you're sitting low to the water. So you can look right through the water at the bottom, and a lot of times you can see mussels. And then we'd stop periodically, do snorkeling searches, so we can do some timed semi-quantitative work. But in this stretch, from Warrensburg down to Thousand Acres Resort, the river really opens up. It's kind of wide and shallow, and I try to imagine this time of year and in the spring that it's probably very, very high velocity, a lot of churning. And it's divided by lots of islands, lots of channels, and so we divide up and go around different areas of the channels. And in this stretch, we didn't find any mussels. We found a couple of dead floater shells in a little inlet, but we didn't observe any live mussels. But we found 3 wood turtles. And this is one of the really cool things. When you work with people from, like, more scientists, they bring in their expertise. And so we had this team of scientists from DEC that went with me in these journeys. And Adam Haynes loves reptiles and amphibians. And he was able to identify this. He said he's looked for wood turtles like his whole career. And he's found 1. We found 3 this one day in the Hudson. And they're listed as special concern in New York State. So we reported that to New York Heritage Program, so of interest. But these were really beautiful turtles. So then as we kept going down, we'd skip a little ways, get an access point. This area is amazing. I live up toward there, like a half hour away from this. I didn't know this area existed on the Hudson. It's part of the Lake George Wild Forest. It's the Hudson River Management Area. And there are access points periodically all around state property. Beautiful river for all ages to canoe and kayak. It's astounding. So we picked a up and downstream location. And this is our team. But the river's pretty gentle. A series of shallow, kind of riffly areas and pools. Great swimming spots. But we were able to observe through the water, look for mussels along the shorelines, and then we'd stop periodically at a spot like this and do a timed snorkel survey. And Adam took a lot of videos underwater, which were fantastic, but this is typical, the kind of sandy, gravelly substrate of this area, and then there'd be like logs underwater. And often you'll find a mussel kind of situated near a log, but that kind of helps hold that sediment in there, so it adds stability to the substrate. And we found quite a few mussels in this stretch. So we're seeing increasing levels of mussels as we go downstream. And we found 3 species. So dominated by Elliptiocomplanata, which is very common in this area, and then 2 other species. So then we started going into areas that have pools. So areas of the river that are divided by a dam and a pool upstream. And so in order to sample that, we need to use divers. So I grabbed a couple buddies from DEC who like to dive with me, and Zoe, and we went out in the river. And this section is accessible by boat, and it has more houses and cabins and more boat traffic, so we just have to be a little careful. One of the things that we often see, and one of our friends in the river, are smallmouth bass. So this isn't going underwater and going, oh, there's a fish and it swims away. Smallmouth bass seek you out and come up to you and go, hey, buddy, how's it going? They're the only species that does that in fresh water. Whoop. So they are, I call them the puppy dogs of the Hudson River. But also, as you notice, in the water, this is the sand bottom. This is perfect for walking around in recreational sand. It's like being at the beach, but not great for mussels. Because if you notice that there was this snowbank kind of in the sand, that's from all the current moving the sand and washing it away. So not a good spot. We don't often see mussels in these kinds of areas. But sometimes if there's submerged aquatic vegetation or weeds, this is beautiful native wild celery, Vallisonera. That can kind of hold the substrate together. And then around that, you see that same sand. But in this section, we did see quite a few mussels, 2 species. And then our last section is below Spire Falls Dam. And this is a power dam. Downstream is Sherman Island Dam, also a power dam. And this is along Moreau State Park. So it's also another great access road where there's a lot of inputs. And this doesn't have as much boat traffic. Really nice. This is a bouldery area. We're docked at an island. And really huge boulders like canyons almost under the water. And often here we'll see mussels wedged in between cobble and boulders like this. And then downstream, we came across areas of really kind of fluffy sediment, but there were so many mussels. All these little gravestones, those are all mussels. It was completely covered in mussels. And if you look closely, you'll see that they're siphoning. All those mussels are little workhorses siphoning the water as it passes by. And here Adam's picking up a couple different species. That's a Lampsillus radiata with the green rays on it. And we found oodles of mussels. And what was interesting is that a lot of distribution among other species, too. And one of the really cool things that we sampled in September, we had the gift that Lampsilus radiata happened to be trying to attract fish. So a lot of times we'd see them, and they had this swollen packet of Glycidia that they're trying to have the fish attack, and they'd have their lure. This is a little appendage that they were twitching, trying to attract the fish. And so that was really interesting to be able to watch them. So if we look at the whole progression from the headwaters down to the bottom of this survey effort, these are the numbers of mussels that we had in each sampling effort. And if I standardize that per time, per sampling effort, you can see that there are mussels throughout almost nearly the entirety of the Hudson River. They may be more rare at the upper portions, but there certainly are mussels throughout our sampled area. A little bit of a question mark maybe at the very beginnings we'll get back to. And then at the lower ends in the pools, very dense populations of mussels. So why is it important to do these surveys? If you don't have baseline numbers of knowing in each river, and I think this is a really good example, you can't just assume that, oh yeah, there are mussels in the Hudson River. It changes dramatically. The Hudson River is very dynamic. From each section, it was like, I mean, you would have thought you were in a whole different river. Very different ecology, different hydrology. So unless we have a survey of each location, if something happens, climate change or who knows, an oil spill or whatever happens, a disturbance to the mussels, unless we've had a previous survey, there's no way to know what the damage is from the disturbance. So these are very important. And only by having surveys are we able to say what is the relative functional importance or the service provided by the mussels in that lower part that we sampled since 2013 compared to the upper reaches. And then lots of times we try to find grant funding to support our research efforts. Projects like this, it's very difficult to find grant funding. And a long-term project extending for over 10 years is nearly impossible. But by having collaborative relationships like what we have with DEC and expanding that to other institutions, we can try to maintain these long-term projects, because that's where you can see trends over time. So in the future, we're going to continue to do our sampling to look at recovery after disturbance in the remediated stretch. But also we want to get back into some of these areas where we haven't sampled yet in the upper Hudson, and even look at the tributaries that come into that to really help define the watershed. So I'd like to thank the people who helped me with these surveys, Jake Madden, our intern, the folks from Bureau of Ecosystem Health, and Liz Clohessy and Scott Jameson, who helped with the previous surveys. And thank you for your attention. I'm going to let this run as another little last taste of summer. Thank you. Thank you very much.